Good morning, students. This is next chapter, that is metals and non-metals. This is third chapter in chemistry part. Already we have completed two chapters. I hope that you are very clear about the two chapters. Now the chapter is metals and non-metals. We know elements are classified into metals and non-metals based on their properties. Properties means either physical properties or chemical properties. So you have to know first what are metals and what are non-metals. So there are some points regarding that one, that is for these are activities. By using these activities we can say some points regarding metals and some points regarding non-metals. For example, take samples of iron, copper, aluminum and magnesium. Note the appearance of each sample. We take four samples here: iron, copper, aluminum, magnesium. If you take those four samples, if you get those four samples, if you see their surface, then you can say that you can feel that they have shining property. That means luster property. From that we can say that these are metals. So metals have luster property, that is called metallic luster. And one more activity, that is clean the surface of each sample by rubbing them with sandpaper and note the appearance again. Here we take again four samples. Now we rub them with sandpaper. We have to observe again. Then they become more shiny because already they have shining property. They have luster property. If you rub them with sandpaper again, they become more shiny. So from these two activities we can say that is metals have luster property. All metals have luster property. That is the first thing. And second one is one more point. Take samples of iron, zinc, lead and copper. These are also metals. Strike them or beat them 4 or 5 times with hammer. What do we observe? So if you beat them, these metals with the hammer, after some time all these metals become sheets. So what is the point here? If you beat metals with the hammer, they become sheets. That means that property is called malleability. Malleability means if any metal can be made into sheets is called malleability. Similarly, metals have one more property like that. That property is called ductility. Ductility means if any metal make into wires, that property is called ductility. Malleability means making of sheets. Ductility means making of wires. So the point here is metals have luster property and metals have malleability and ductility. And one more activity is there. If you take these four samples, cut with them with a knife, then what is your observation? I repeat once again. Take the same samples, that means iron, zinc, lead and copper. Cut them with a knife, then what is your observation? Here our observation is we cannot cut them knife easily. We cannot cut them with a knife easily. That means they have very strong. That means from this we can say that they have strong more melting point and boiling points. Metals have more melting points and boiling points. What are these? All these are properties, physical properties of metals. From these two we can say that metals have luster property. From this we can say that metals have malleability and ductility. And just now we discussed one activity. From that we can say that metals have more melting points and boiling points. Next, there are some more points regarding metals. That is, all metals are present in solid state. All metals are present in solid state except mercury. Very important point. So except mercury, all metals are present in solid state. Mercury is present in liquid state. So the liquid metal is what? Mercury. This is very important bit. All metals are present in solid state, but mercury is present in liquid state. Next one. Just now we discussed about malleability and ductility. Among all metals, gold. Its symbol is Au. It has more ductility. So which metal having more ductility in nature? Gold has more ductility. You will surprise one thing, that is, by using 1 gram of gold we can make 2 kilometers wire of gold. I repeat once again. By using 1 gram of gold we can make 2 kilometers of gold wire. That means gold has that much ductility nature. So the most ductility nature of metal is what? Gold. Ductility means what? If a metal becomes into wire, that nature is called ductility. And one more point, gold and silver are more malleable metals. Malleability. Gold and silver have more malleability. Malleability means making of sheets. Ductility means making of wires. So gold is the more ductility metal and gold and silver are more malleability metals. Next, one more thing. All metals conduct electricity. All metals conduct electricity. But some metals exhibit more electricity, some metals exhibit less electricity. We will discuss those points later. So that is also one of the physical property of metals. All metals exhibit electricity. Next one, non-metals. Compared to metals, non-metals are very less in nature. That is the first point. Compared to metals, non-metals are very less in nature. There are few non-metals compared to metals. For example, carbon, sulfur, iodine, hydrogen. All these are non-metals. Here important point is, all non-metals present in solid state and gaseous state except bromine, that is present in liquid state. The liquid non-metal is only bromine. This is very important bit. Most of the non-metals are present in solid state and gaseous state. The non-metal which is present in liquid state is what? Bromine. All metals are present in solid state except mercury, that is present in liquid state. All non-metals are present in solid state and gaseous state except one, that is bromine, which is present in liquid state. Next one. For example, take carbon. This carbon is present in nature in different forms. They are diamond form, graphite form, fullerenes forms. I repeat once again. This is carbon. Carbon is present in nature in different forms. They are diamond, graphite, fullerenes. Similarly, coal, coke, all contains carbon. All these are present in solid state, but they are having different structure. These are different structural formula. This property is called allotropy. We will discuss later in next chapter. We will discuss about what is allotropy. Until that, you just remember carbon having different allotropic forms. They are diamond, graphite, fullerenes, coal and coke. Next, there are some more points regarding this one, that means metals and non-metals. Iodine is the only non-metal which exhibits luster property. So the only non-metal which exhibits luster property is what? Iodine. The only liquid non-metal is bromine. The only liquid metal is mercury. You should remember all these points. Next one. All metals exhibit electricity, and all non-metals do not exhibit electricity. That means all non-metals do not exhibit conductivity except graphite. Graphite is the one of the allotropic form of carbon. So the non-metal which exhibit conductivity is what? Graphite. Graphite is the only non-metal which exhibit conductivity due to the presence of free electrons. That we will discuss later. That means later means in next chapter we will discuss about that point. Next one. In the beginning, I told one point, that is all metals having more melting point, but one exception is there. 1A group elements, that is lithium, sodium, potassium, rubidium, cesium, all are metals, are present in solid state. But here the point is all these metals can be cut with a knife, so that these metals are called soft metals. Why these metals can be cut with knife? Because the attractions of particles present in these metals is very less. So we can say that these are weak metals. So the melting and boiling point of these metals is very less compared to other metals in the periodic table. So these metals can be cut with knife because of less attraction forces of particles present in these metals. So these are the points regarding metals and non-metals. This is introduction part. Now chemical properties of metals. Chemical properties of metals. First one, when metals with oxygen, that means when metals reacts with air, then metal oxides are formed. When any metal reacts with oxygen, then metal oxides are formed. These metal oxides have basic nature, because when these metal oxides reacts with water, they form hydroxides. That is why all metal oxides are basic in nature. Next, here one point is there, that is sodium and potassium. They are metals, 1A group metals. They vigorously reacts with oxygen in air, so that they kept under corrosion. So this here one question is there, why sodium and potassium kept under corrosion? The answer is what? Because they vigorously reacts with oxygen. Next, one more point. Magnesium, aluminum and zinc, when they reacts with oxygen, then they form respective oxides. Then those respective, that means suppose for example when magnesium reacts with oxygen, magnesium oxide is formed, but that magnesium oxide cannot react with further substance. That means further reactions will be prevented because of oxide layer present around its surface. I repeat once again, the metals magnesium, aluminum, zinc, when reacts with oxygen, they form oxides, but their further reaction will be prevented due to the presence of oxide layer around its surface. So that is about metals with oxygen. Next one is metals with water. In previous lesson we discussed already about this point. When metals reacts with water, they form metal hydroxides and hydrogen. For example, take sodium, potassium. When the sodium, potassium reacts with water, they form hydroxides along with the hydrogen gas. Here one more point is there, like here, that is aluminium, iron, zinc. These metals do not react with cold water and hot water. These metals react with cold water and hot water. Aluminum and iron, they both react with steam. Not with steam means water vapor. They can react with steam, but these both do not react with cold water and hot water. Then what about zinc? Zinc having oxide layer around its surface, so that zinc cannot react with water. Next, very important points. The metals lead, copper, silver and gold, they cannot react with any water. That means any water means either cold water or hot water. So these are the points regarding metals with water. Next one, metals with acids. This point also came in previous lesson, that is when metal reacts with acid, then salt and hydrogen gas is formed. For example, when zinc reacts with HCl, then ZnCl2 and hydrogen gas is formed. For balancing purpose, here we put 2. And one more equation, when zinc reacts with H2SO4, then ZnSO4 and hydrogen gas. So the point is what? When any metal reacts with acid, then salt and hydrogen gas are formed. Next, here one important point is there, that is HNO3. Its name is nitric acid. That means it is acid. When any metal reacts with nitric acid, then water is formed instead of hydrogen gas, because this nitric acid having strong oxidizing nature, strong oxidizing agent. Because of that nature, HNO3 itself reduces to NO2, so that it cannot liberate H2 gas, it liberate H2O. I repeat once again, HNO3 name is nitric acid, that means it is acid. When any metal reacts with this one, then this metal releases water instead of hydrogen, because it has strong oxidizing nature. Because in this one, NO3 minus ions itself reduces to NO2. So because of that reason, it cannot liberate hydrogen gas. Next, there are some more points regarding this one. Some metals like copper, silver and gold, they do not react with acids. So which metals do not react with acids? Copper, silver and gold. Next, some more points. Some metals like magnesium, manganese reacts with dilute HNO3. That means this is not oxidizing agent. Then they liberate hydrogen gas. So very important point. Which metals reacts with dilute HNO3 liberate hydrogen gas? Magnesium and manganese. These metals do not react with any acid at all. When these metals react with dilute HNO3, then they liberate hydrogen gas. So these are the properties of metals and non-metals. There are some more topics are there in this one. We will discuss those topics in next video, next class. Thank you.